Okay, so a key thing for the actual AP exam, okay? Not only do you have to have all the 5-star theorem memorized and know how to do all of this stuff, but they're going to rewrite the first fundamental theorem of calculus like this a lot, okay? You're going to see, especially in Fourier responses, where you're trying to solve for f of b, and so you're going to have to use this, okay? So remember that the fundamental theorem says that if you go from a to b of f of x dx, okay, they're just saying this is the derivative, okay, equals, then you do f of b minus f of a, okay? So if you rearrange it and you get f of b by itself, you end up adding f of a to the integral, okay? Writing it this way allows you to evaluate the integral and then use the value of f of a to find f of b, okay? So like on Fourier response questions, they'll give you a graph where you can find like the area and get this part, and then they'll tell you what f of a is, or you'll be able to tell from the graph what the first value, y value was, and then they want you to figure out what this is, okay? You could also rewrite it to find f of a like this. So here's the fundamental theorem of calculus, and then if you wanted to get f of a by itself, I would add f of a over here, and then subtract the integral to the other side. So f of a is f of b minus the integral from a to b, f of x dx, or f double prime of x dx, okay? So you're going to see that a lot on the exam. I'm thinking after spring break, I'll probably start pulling AP exam old questions and use those as examples to teach you the rest of the stuff for the course. That way you're getting like practice for the exam at the same time as notes. Okay, and another thing down here. Okay, so net change theorem. Basically it's saying the definite integral of a rate of change of a quantity, so capital F prime of x, gives the total change or net change in that quantity from a to b. Okay, so basically they're saying, so we know that integrals give us area, but they're also saying if you take the definite integral, then you end up getting a net change. You get how much something changed, okay? Which will make sense when you look at some problems for that in just a little bit.